dear aspirants, welcome to Dr. Souras's classes, and in this video I'm solving RBI grade B DSIM, that means Department of Statistics and Information Management. इसी का जो एक पेपर है दैट इज पेपर 2 डिस्क्रिप्टिव पेपर टाइप स्टैटिस्टिक्स, उसी पेपर का प्रीवियस ईयर सॉल्यूशन. If you want to take classes from our side or want to take doubt clearing session, previous year question solution, mock test, study material, any of that, please don't hesitate. Please call or WhatsApp on this number. Dr. Sasasam says reply to your query individually through WhatsApp. So already all you all know that statistics related कोई भी एग्जामिनेशन के लिए सोर्सेस क्लास इज द बेस्ट कोचिंग इंस्टीट्यूशन इन इंडिया में है. तो आप में से कोई भी इस कोर्स के लिए अगर प्रिपरेशन लेना चाहते हैं तो डोंट वेस्ट टाइम. दिस इज द बेस्ट टाइम टू टेक एडमिशन इन डॉक्टर सोर्सेस क्लासेस एंड बूस्ट अप योर प्रिपरेशन विथ डॉक्टर सौरभ सर. तो अभी भी एडमिशन कोई भी लेना चाहते हैं तो हमारा इस कोर्स में ज़्यादा से ज़्यादा हम डिस्काउंट प्रोवाइड कर रहे हैं. ओके, so don't waste time. This is the best time to take admission in Dr. Sourab's classes and boost up your preparation with Dr. Sourab sir. So let's start with question number 11a. What will say the question number 11a? In that question, they will say that the two gamblers A and B bet on the successive independent tosses of a coin that lands just to it, yeah, so that lands heads up with probability P. If the coin turns up heads, gambler A wins and a rupee from gambler B. If the coin turns up tails, then the gambler B wins a rupee from gambler A. Thus, the total number of rupees among two gamblers stays fixed, say in. So, the game stops as soon as either the gambler is ruined. Describe this as the Markov chain and found its stationary distribution. Is it the limit distribution? The question will ask. So, how can we solve that question? So, if we can take the total number of rupees between two gambler stays fixed at n, stays fixed at n, which means if A has I rupees, which means if A has I rupees and B has n minus I rupees. So and the game ends when either gambler is ruined, when either the gambler is ruined, that is when either gambler has 0 rupees. That means absorbing state. Okay, so we are asked to the model, this is a Markov chain, find the stationary distribution and check if it is the limit distribution or not. So first of all, we can describe the game as Markov chain. Let here xn denote the number of rupees that gambler A has in a toss, since the total number of rupees is what? N. and B has any moment in is n minus xn. Since the possible state of game xn are what? 0, 1, 2 up to n. Sorry, 0, 1, 2 up to n, where state 0 A has 0 rupees. A, that means A is what? A is ruined, and state n, state n, that means A has all n rupees. That means B is ruined. So the states 0 and n absorbing, that meaning once the game reaches these states, if it stops, and the states are 1, 2 up to n minus 1 are transistent, meaning the game continues until one of the absorbing state is reached. So the transition between the states depend on the outcome of each coin toss. That means if the coin lands head with the probability xn increases by 1, if head with the probability xn is increases by 1, and A wins. A wins rupee, and if the coin lands tail with probability 1 minus p, here the probability for p, and if coin tails, then the probability is 1 minus p. That is xn decreases by 1, xn increases by 1, and xn decreases by 1. That means B wins rupee. Okay, so this Markov chain transition probabilities, that is here probability of xn I plus 1 such that xn equals to I equals to p, A wins rupee. A wins what? A wins rupee. And probability of xn equals to I minus 1, that means such that xn equals to I, that is 1 minus p, that is B wins rupee. And probability of xn equals to 0 such that xn equals to 0 equals to 1, and a probability of xn equals to n such that xn equals to n equals to 1. That means what? Absorbing state. And here the transition matrix for that to absorbing, p equals to 1 minus p, 0 up to 0 0, and here the matrix are 0 0 1 minus p up to infinite level, and here 0 p 0 up to infinite 0 0, and that is to infinite 0 p finite 1 minus p 0, and here that continues 0 to 0, that continues again 0 0, and here 0 0 continuing up to continue p1. This is the transition matrix, and state 0 and 1 absorbing with probability of 0 0 is 1, and probability of n also what, 1. For I less for 1 less than equals to I less than equals to n minus 1, the probability of I comma I minus 1 equals to 1 minus p mod p of probability of I comma I plus 1 equals to phi. So we can now finding the stationary distribution. A stationary distribution pi stationary distribution pi, that is equals to pi naught pi 1 up to what, pi n. So here pi equals to pi p equals to pi, and here summation of I equals to 0 to n pi I equals to what, 1. So for observing here pi naught equals to probability of gambler A is ruined, and pi n, that is probability gambler B is ruined. Since the Markov chain is absorbing, the stationary distribution places at the probability pi naught, that is equals to probability pi naught, that is equals to probability xn eventually reaches 0, and pi n p probability of xn eventually reaches n. Okay, so the probability is pi, that is probability of probability pi plus 1 plus 1 minus p into pi minus 1 with boundary condition p naught equals to 0 if A is ruined and B wins, and Pn equals to 1 if B is ruined, then A wins. Solving the recurrence leads to Pi, that is 1 minus p whole to the power I by 1 minus p whole to the power n. Thus the probability the game ends with gambler B ruined start from I is Pi, and the stationary distribution is then pi naught equals to probability of A is ruined. That means 1 minus p whole to the power n, 1 minus p whole to the power I, that is 1 minus 1 minus p whole to the power n. So now the limit distribution is that the stationary distribution, in case some limiting distribution Markov chain is absorbing, the limiting distribution is always concatenated to the absorbing states, that is therefore as n tends to infinite. Okay, then the Markov chain eventually end up with one absorbing states, that is 0 or n. Okay, thus the limiting distribution is limit n tends to infinite, probability of xn equals to I, that is probability of A is ruined and probability of B is ruined and 0 if I equals to 0 if I equals to n and 0 otherwise. Okay, so this matches the probabilities absorption is not reflected as typical distribution, that's positive transit state. Okay, so that's all about that, and thus the stationary point usual sense does not exist here because of the absorbing nature, so the limiting distribution is concatenate on the absorbing state. So that's all about that. We will meet you in next session soon. Thank you.